Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on waves from October-November 2022 paper 1. In the last two videos, in part 01 and part 02, we have discussed all 20 questions. And if you need solution of those questions, you can go to the channel and you can check for October-November 2022 paper 1, part 01 and part 02. And today's lesson, we will discuss all the questions on waves from this paper, and I will explain you these questions in detail so you can improve your conceptual understanding and also you can have better understanding of these questions. Let's study together. Let's improve together. For question number 21, it is given to us the diagram shows a transverse wave on a rope. The wave is traveling from left to right. At the instant shown, the points P and Q on the rope have zero displacement and maximum displacement respectively. Which row describes the direction of the motion if any of the points P and Q at this instant? Now, first of all, we need to understand this question. We can approach using a long method or we can approach using a shortcut, means short method. The first thing you need to understand, as in this case, wave is moving to the right. So these particles, they will follow the coming wave. They will follow the coming wave. Mean this particle will go down and this particle also will go down because this particle will follow this part of the wave. So it will follow this part of the wave, means the coming wave. So this particle will go down and this particle will follow this part of the wave, mean this is coming wave. So this particle also will go down. Now for answer, it is given to us. If you look at option A, particle P is moving down, means particle at point P is moving downwards. So this one is true. And also we need to understand the particle at the top, means at this point the speed of this particle is equal to 0 and speed of particle at equilibrium, this is maximum. So we can say V is maximum. And if the particle is located at the bottom, mean this speed also will be maximum. So we can say speed will be 0, not maximum. If at the peak or at the bottom, speed will be 0. So speed here also will be equal to 0. Now based on these concepts, mean based on this understanding, we can find the answer. Particle at point P, it will follow the coming wave, so it will just go down. So we can draw the arrow. This particle will go down. Particle is here. This particle will go up because it will follow the coming wave. So particle here, this one will go up, and particle at the top, it will go down because it follow the coming wave. So this is a simple way, because for multiple choice questions you have only 1.8 minutes, so you need to understand the quick way to answer these problems. So simply you can understand particle will follow the coming wave. So particle at point P, it will go downwards, and point Q at that instant, this is stationary. So it means A, this one is true, this is true, this is true, so the answer can be A. But if you go to B, stationary, particle at P, point P stationary, no, it has the maximum speed. This one is moving, so this one is wrong. Q is moving downwards, this is right. Stationary, not right. Moving upwards, this is wrong. Moving upwards, this is wrong. Particle at point Q stationary, this one is right. So the answer for this question is A, and this is how you can approach. For question number 22, it is given to us the period of an electromagnetic wave in a vacuum is 1.0 nanoseconds. What are the frequency and wavelength of the wave? So we need to calculate frequency of the wave and we need to calculate wavelength of the wave. Frequency of the wave simply is equal to 1 over time period, and time period of the wave is given to us. So this is 1 over 1 nanosecond. 1.0 times 10 to 9 minus 9. This is 10 to minus 9. So it simply means that the frequency will be equal to 1.0 times 10 to 9 hertz. So this one is the frequency. Now we need to calculate speed of the wave, and we need to calculate wavelength of the wave. And speed of electromagnetic wave is in the vacuum. All electromagnetic waves, they have the same speed, and speed is equal to speed of light. So we can write down lambda, the wavelength. This one will be equal to V divided by frequency. Speed of electromagnetic waves in vacuum is 3.0 times 10 to 8 meters per second, and frequency we have calculated, that is equal to 1.0 times 10 to 9. So simply we can write down this will be equal to 3.0 times 10 to minus 1, or we can say this is equal to 0.30 meter. So this is wavelength. So in this case, answer is C. For question number 23, it is given to us an observer is standing on a railway platform. A train passes the observer at constant speed while emitting the sound of constant frequency f from its whistle. What does the observer hear? So this is a typical type of question. So we can simply imagine that an observer is standing on the platform. So we can imagine observer is standing on the platform. So this one is the platform, observer is standing on this one. So we can draw first of all when the train is approaching. So at this point, train is approaching. So we can say train is approaching this observer. So this is when train is approaching. And here we can draw when the train is moving away. So we can say train is moving away from the observer. When the train is approaching, observed frequency by the observer, this one will be greater than frequency of the source. And when this train is moving away from observer, observed frequency will be lower than frequency of the sound produced by the whistle. So this is what you need to understand to answer this problem. Now let's try to find out the answer. For option A, it is given to a sound of decreasing frequency. Actually, sound frequency will be constant. It will be higher or it will be lower. Decreasing frequency, this one is wrong because this is when train is approaching. Increasing frequency will not increase. Actually, frequency, when if the speed is constant, there will be constant frequency higher and constant frequency lower when the source is moving away. So option A is incorrect. If you look at option B, sound of higher frequency, and frequency will be constant. So this is possible when the train is approaching higher than f, and lower frequency than f as the train moves away. So this is possible answer. If we go to C, sound of lower frequency than f, train approaches, this is wrong. This has to be higher. This is higher, this is wrong. It has to be lower, then moves away. Sound of an increasing frequency as the train approaches and as it moves away. Increasing frequency will be constant but higher when the source is approaching, constant and lower when the source is moving away. So this is also wrong. So the answer for this question is B. For question number 24, we need to find out which organisms have a length that is equal to the wavelength in free space of an electromagnetic wave that is visible to the human eyes. So this question is simply about visible light, the wavelength of visible light. And wavelength of visible light is about 400 nanometer to 700 nanometer. And 1 nanometer, if you look at these answers, they are given in micrometer. So it's better we can write down this one in micrometer. 1 micrometer is equal to 1000 nanometer, or simply we can say 1 nanometer. This is equal to 10 to minus 3 micrometer, and we can change this one into micrometers. So we have 400. So let's try to convert this one. 400 nanometer. We can say this is 400 nanometer. We want to convert this one into micrometer. So we can divide by 1 nanometer, and 1 nanometer is equal to 10 to minus 3 micrometer. So nanometer, we can cancel the nanometer. So simply we left with 400 times 10 to minus 3 micrometer. It simply means that this is equal to 0.40 micrometer. So now from here we can simply write down wavelength of visible light. This one will be equal to 0.4 micrometer to 0.7 micrometer. Now simply we can find the answer. If you look at the first option, this is 0.5 and this is in this range. So our answer for this question is A. This is not possible because this is 5, so this is not possible. 50 not possible, 100 not possible. So the answer for this question is A. For question number 25, it is given to us two progressive waves overlap. What is an essential condition for the two waves to form a straight stationary waves. The waves are longitudinal. This is not necessary. This is not essential condition, because transverse waves, they can also form stationary waves. The waves are polarized. This is also not requirement for formation of stationary waves. The waves travel in opposite direction. This is the requirement. The waves have to travel in opposite directions. The wave travel in the same direction. This is not required for stationary waves, but this is required for beats, and that is not part of your syllabus. So the answer for this question is C. The waves must be traveling in opposite directions so they can form stationary wave. For question number 26, it is given to us, in an experiment to produce stationary sound wave in air, a fine powder is initially evenly distributed along the length of a horizontal glass tube which is closed at one end. At the open end of the tube, a loudspeaker emits sound wave of constant wavelength. A stationary wave is formed and the powder accumulates in equally spaced piles as shown in the figure. This statement explains the positions of the piles of powder within the tube. Now in this case, we are talking about stationary sound wave. And in sound wave, particles of the medium, they move along direction of the wave, means parallel to the wave. So first thing we need to understand. And the second thing we need to understand, particles on two sides of same node, they move in opposite directions. So let's say we have a node here. So this point is a node. Let's say here we have, this one is antinode. So this one is antinode. And here, let's say we have also antinode. Now we need to understand how particles will move. First of all, imagine that particle on this side of the node, let's say they're moving to the right, and the particle on the right side, they will be moving to the left. So these particles, they will be moving in opposite directions. So this point is very important. You need to understand, on two sides of the same node, particles move in opposite directions. Means they are in opposite directions, or simply you can say in antiphase. So opposite directions, or you can say antiphase. So the phase difference is equal to 180 degrees. Opposite directions, phase difference is equal to 180 degrees. And this is the knowledge you need to answer this problem. So if this is node, let's say you can take any point, for example. So you need to understand, as in case of this node, powder means particle of medium, they will move in opposite direction. So what will happen at this point? Powder will accumulate. So we will see powder that will accumulate. So we'll see a pile of powder at the nodes. So it means these points are nodes, because particles here, they will move to the right. Just imagine that. And particles here, they will move to the left. So powder will accumulate at these points, and these points, they will be nodes, means they have minimum amplitude. Now let's try to find the answer. If you have understanding of this one, now easily you can find the answer. The piles are where air molecules vibrate with maximum minimum amplitude, because nodes, they have minimum amplitude. The piles are where molecules vibrate with minimum amplitude. Yes, because on other side, particles have higher amplitude, so they will push piles of powder towards node. So at node, there will be piles of powder. So this can be the possible answer. So this one is possible answer. The piles are where air molecules vibrate with the highest frequency. Actually, all wavelength is constant of this wave. It means all molecules, they have the same frequency. So this one is wrong. The piles where molecules vibrate vertically, molecules are not vibrating vertically. They move along direction of wave, because we are talking about stationary sound wave. So this one is also incorrect. So the answer is B. This is the point you need to understand. On two sides of same node, particles move in opposite directions, or simply you can say they have phase difference of 180 degrees. So powder will move, means from this side, powder will move to the right. This side, powder will move to the left, means those are medium particles. So powder will be accumulated at nodes. So this is how we can approach this problem. For question number 27, it is given to us, a sound wave of wavelength 0.50 meter passes through a doorway of width 1.0 meter between two rooms. Which change increases the amount of diffraction that takes place? Typical type of question about diffraction. So first of all, we need to understand when significant diffraction will take place. What is condition for that? Significant diffraction. Significant diffraction takes place significant diffraction. It will take place if wavelength is about equal to the gap size, So diffraction will be significant. Now, if we increase the wavelength, if we increase lambda, but we keep this gap size same, in this case, there will be more diffraction. We will say there will be more diffraction. So this is one thing you need to understand. There will be more diffraction. But if we keep gap size same and we decrease this wavelength, there will be less diffraction. So if you have understanding of this one, now simply you can find the answer. If we look at option A, double the amplitude of the sound wave, it has no effect on diffraction amplitude. So it means this option is incorrect. Double the width of the doorway, if you increase this one, you keep this one same, there will be less diffraction. So there will be less diffraction. So we need more diffraction. So it means B is also incorrect. So this is incorrect. Half the frequency of the sound wave. So if we decrease the frequency, it means that we are increasing the wavelength. If we keep gap size same and we increase the wavelength, this one will be equal to this one. We'll be getting closer. So it means in this case, we will observe more diffraction, because when frequency is half, wavelength is double. So double means this is 0.5 double, this is 1.0. So there will be significant diffraction. It means diffraction will increase. So this one is possible answer. Half the period of the sound wave. If period is half, it means frequency is double. Frequency double means wavelength is half. Means this will be 0.25. There will be less diffraction. So means there will be less diffraction. So D is also not possible answer. So the answer for this question is C. Typical type of question, and this is the knowledge you need for this type of problems. For question number 28, it is given to us a light source consists of a vertical slit illuminated by red light and violet light. The wavelength of red light is approximately twice the wavelength of violet light. A parallel vertical double slit is placed nearby. A white screen is placed so that fringes are formed on the screen. Which graph best represents the interference fringes formed on the screen? So this question is about double slit. For double slit, we need to understand fringe spacing x. This is equal to lambda d divided by a. A is slit separation, distance between slits, center to center. So this is slit separation. So we can write down this is slit separation. And d is the distance between double slit and screen. So simply we can say this one is the distance. Now in this case we have two lights. One is red and one is violet. And it is given to us that the wavelength of the red light, this one is equal to 2 times of the wavelength of violet light. So we can say 2 times of V. Better we can say 2 times of wavelength of violet light. So we can write down wavelength of violet light. So we can say 2 times of wavelength of violet light. Now we can compare red and violet. We can compare. So first of all, we can write down for the violet. Violet, and on this side, we can write down for the red. So this one is for red. For red light, we need to understand first order fringe spacing. So I will be writing here first order. The fringe spacing, we can say x1, that one will be equal to lambda of red times d divided by a. But if we compare this one with violet light, we can say x1 in this case will be equal to 2 times of lambda of the violet times d divided by a, because the wavelength of red light is twice the wavelength of the violet. So it will be at a distance 2 lambda capital D divided by A. And this is wavelength of violet light. So this is the first order. Now if we write down for the violet light, the first order, we can say x1. This one will be equal to lambda capital D divided by A. This will be the first order. And the second order fringe, this one will be equal to 2 times lambda capital D divided by A. Now if you compare this x2 with x1, they are the same. So it means where we see the second order fringe of violet, at the same we will see the first order of red. So this is what this is telling us. So in this case I can also write down x1 x1 is equal to x2. So I can say that is equal to x2 means for the violet. It simply means that where we see first order of red, at the same position we will see second order of violet, and that's the point you need to understand. If you got this point, now we can find the answer. And also we need to understand at the center means zero order, center maxima. We will see violet and we will see red. We will see the combination of these two. And if I draw here, first of all, you will see the violet. You will see violet here. And at this point, the second order, you will see violet and you will see the red overlapping at this point. So I can simply draw here overlapping. At bottom side, we will also see here, first of all, violet. We will see violet here, and here we will see the second order of violet, but this will be overlapped by first order of red. Now, if you have this understanding, so we can find the answer. If you look at option A, this one is 100% not possible because this is telling us the minima at that one. Here will be maxima. So this is not possible. This is telling us only violet, no red. This is also not possible. And if you look at this one, it's telling us red is inside, violet is on the outer side. That is not possible. If you look at this order here, it must be violet, not red. So this one is wrong. So this is also not possible. Here it should be violet. It should be violet, not red, because first order violet, then red. Now if you look at this one, you will see you have violet, you have red, violet and red. So it means that this one is possible because first order we will see this is violet, means you will see the violet here, and here you will see violet and red, and also violet and red together we will see, as you can see here. So this side is also true. It means this one is possible answer. So C is the possible answer. So this is possible answer. Let's try to understand a little bit more about this one. Maybe some of you will be confused, or maybe you need some more detail why this one is inside, why the violet is inside and the red is on the outer side. The reason is that we have seen from here, as the fringe spacing for red is greater than fringe spacing for the red, as this is 2 times greater than the fringe spacing for the violet. It also means that the size of the bright fringes of red is greater than the size of bright fringes of violet. So that's the reason we see in this case red on the outer side and you see violet means inside. So that's the reason. So the red bright fringes, these are wider. The size is bigger than the size of the violet. So that's the reason inner side we have violet and outer side we have red bright fringes because the size is bigger. So that's point you need to understand. So that's the reason we see, if you look here, we have the red outside and we have violet inside. So you can see this is the red, this one is outside, and inside we have this one is violet. So inside we have violet. Let me use different color. So let me use this color for the violet. So we have violet inside and we have red outside because the size of bright fringes of red is greater than the size of bright fringes of violet. So that's the reason you see outside. So if fringe spacing is greater, it also means that the size of the fringes is also greater. For question number 29, we need to find out which property of a light wave can be determined using a diffraction grating. If you look at formula of diffraction grating, we have d sine of theta. This is equal to n times lambda. So from here we can find out the lambda of a wave using diffraction grating. So we can find out wavelength of a wave, and that is property of a wave. So simply answer for this question has to be D, because we can determine the wavelength of a wave using diffraction grating. Amplitude not possible. Intensity we cannot determine. Speed we cannot determine. So the answer for this one is D.